Okay, so this is a practice for our test that we're going to be having next week. There are going to be 3 different types of questions: mathematical accuracy, where you need to solve the problem and show the work, show your math work. That second part, showing your work, is going to be important. To get full credit, you're going to need to show something there for a lot of these problems, show the steps. Constructing arguments, this is where we're going to be explaining why. So we're not just going to be solving a problem, we're also going to have to explain why and how we solved it that way. The third thing is to critique the reasoning of others. So these are going to be problems that are done slightly incorrectly, and we need to find the mistake, find the error, and say why that's not correct. So we'll go through some of each of these types, okay? I'm going to click next. Math accuracy points, they're all worth 5. This is what it says for 5. So to get a full 5, you need to have the whole procedure showing your work and all the details are correct. If you don't have all your work shown, or at least enough work shown and the correct answer, you won't be able to get a 5. So make sure you're doing that, and I'll say what that looks like. So here's our first math accuracy questions. We're doing the distributive property. We have this number outside the parentheses, and it needs to multiply in to everything inside the parentheses. If I write on that, what we're talking about is taking this 2 on the outside and multiplying it times both terms. While you're doing this test, I would recommend maybe having a piece of paper and a pencil and a calculator even handy to do these problems on a piece of paper before you go to type them in. So when I distribute this in, I'm multiplying all those terms by 2. I'm doing 2 times 5x plus 2 times 3, and then minus 9. Be careful, don't distribute to something on the outside of parentheses. 2 times 5x becomes 10x, plus 2 times 3 becomes 6, minus 9. These are the steps that I'm going to be showing in here. I'm going to actually type them out to show my work. And then at this stage, we need to identify any like terms. Remember, for like terms, we need to have the same variable and the same exponent. So I don't have any other x terms, so that one's just going to be part of my final answer. There will be nothing that goes with that. But then I have these 2 constant terms, no x's at all, but they have the same variable, no variable. I can put these together. So I have positive 6 minus 9. That's going to end up with being negative 3. Remember, when we're doing expressions like this, a negative and a subtraction are very, very similar, and we're going to treat them almost the same when we're dealing with these terms. A minus means that there's a negative. All right, so now at this stage is here where I need to transfer my work from either a piece of paper, or I just wrote it right here, into math. When you're typing these things in, to type in the math, I really recommend you use this button here. It opens up this equation editor where it's going to look more like math. And I'm going to show all of these steps. If you need a symbol, like the multiplication symbol, come down here and you can press that button with that keyboard thing that pops up. That gives you some more options to do it. And then I'm just going to keep going. I'm going to try to show as much work as I can. The more work you show on a problem, the more likely you are to get more points. Now, obviously, to get all of the points, the work also has to be correct, but it can't hurt to show your thinking and process along the way. So here we go. I have everything here that it took for me to solve that problem. And you can click submit. You don't actually have to. Whatever you have in here will save automatically. But I like clicking submit just so that I know that I've finished this problem, so that when I go to look back at it again, I'm not confused. I know that I've already done it. If I accidentally click submit and I need to fix it, I can go back and edit it. I just have to hit right here, edit my response, and I can type back in there. I just like to know that I'm done with the question, so I'll click submit. Okay. Next one, same idea. I want to show my work as I'm going. This is simply simplifying this expression. This is a bunch of things that are all added together. So I just need to figure out what my like terms are. So remember, like terms, I need to have the same variable, and the same exponent. If those things are not true, then I can't actually put them together. So here I have x squared. Really, that's 1x squared. If there's no number in front of a variable, we can always assume there's that invisible 1. I have another x squared that has the same variable and the same exponent, x and an exponent of 2. I don't have any others like that that go together, but those can be added together. I can add together 1x squared plus 3x squared to get 4x squared. Those can combine together. And then I also have some x terms. These are both just x's. They have the same variable. They don't have an exponent written there, so they do have the same exponent, so to speak, there. So I can put those together as well, 7x plus 2x. When I add those, I get 9x. And then finally, I have this term 3. There's no other constant term. There's no other just plain number for this problem. So I'm still going to have a 3 with my final answer. Now, my answer is going to need to include all 3 of these terms in it. It's going to have to be 4x squared plus 9x plus 3. All of these terms were positive. That's why I'm writing pluses with them. If any of them were negative, I would make sure to put a minus in front of them. Okay, and then I'm going to go ahead and make sure I type this in. I'm going to show my steps that I did up there. Oops, I forgot. If I'm typing in math, I want to make sure to use this because it's going to look a little better. 1x, to put in an exponent, I had to open up this little keyboard thing. It gives me all my different math operations. Squared is right here. So 1x squared plus 3x squared equals 4x squared. Showing all my steps. Again, it can't hurt. When in doubt, show all your thinking. So it can't hurt to just type in everything that we did to solve this problem. And then the last one was just a 3. So those were all my terms. I had nothing to go with 3, and then our final answer down there at the bottom, make sure I include that. I don't want to leave out the final answer. I really want to make sure you're trying to type in these things as we're going. So like I would mess around and try to type in answers into these Desmos boxes because you're going to need to be able to figure out how to put in an answer like this. Because if you can't type this in, if you can't use the tools here, the equation tool and then this little keyboard tool, you're gonna have trouble taking the test, and that's gonna be unfortunate. All right, once we feel like we've got it all done, I like to click submit, but you don't have to, and you can always edit it again. All right, moving on. So then we have another question in mathematical accuracy. We're supposed to simplify this expression using the order of operations. So hopefully we remember these order of operations, but if not, remember this is a handy mnemonic device. So parentheses, exponents, multiply and divide, add and subtract. This is the order. Anything in the parentheses we do first, then we do exponents, then multiply or divide. Those are grouped together, then add or subtract. With these two steps, they're combined, whichever one comes first. If multiplication is on the left, we do multiplication first. If division is on the left, we do division first. Same with adding and subtracting. So in this problem, what people get confused about with parentheses is just because there are parentheses, that does not mean there is actually a parentheses step. When I look at these parentheses, there is nothing to do inside those parentheses. Parentheses need stuff to do in them. You actually have to have something you can calculate. Here, I just have a number. There's nothing inside of these parentheses I can do. So for this one, I don't have a parentheses step. Parentheses are just another way that we can show multiplication, and they can also, we can put exponents on the outside of parentheses. So sometimes you'll have parentheses with an exponent like that. So parentheses don't always mean that you have a parentheses step. Actually, the first thing that I see here in terms of the order of operations is exponents. So I need to do 3 to the second power. Remember, 3 to the second power means 3 times 3, which is 9. The exponent tells me how many times to multiply that number together. So in this case, it's 2, so there's 2 of them multiplied together. Well, so this becomes 2 times 9 minus 6 times 2 minus 4. So now we've taken care of our exponent. Now we have some multiplication. Whenever you have a number and parentheses together like this, this means we are multiplying these together. Same here, we're multiplying these together. And we do our multiplication from the left to the right. So 2 times 9 is 18. 6 times 2 is 12 minus 4. With this kind of step, since there's 2 of them there together, I can do them both in the same step. I don't have to do them separately. I can do them both in the same step. So I am recording this, guys, in case you're missing some things and you need to look back at it. I am going to record this and have it posted on our classroom page. Okay, so now we've done multiplication and division. There's no division here. Now we need to do our addition and subtraction. Again, it's left to right. So I need to do 18 minus 12, which is 6, and then 6 minus 4, which is 2. When we are doing this, when we're using order of operations, we're looking for a single value, a single number answer. And remember, let's show all our work. So let's show all of these steps here. We don't need to do the lines and stuff, but we can show all the steps that we were doing. So it's 2 times 9 minus 6 times 2 minus 4. My next line, new equation, I have 18 minus 12 minus 4. Next line, 6 minus 4. Last line, 2. I want to make sure to show all the steps that it took for me to do that problem. So that might take you a little extra time to type in your answer, but the more you show me, the more, if you happen to make a mistake along the way, the more credit I can give you, because the more I can see if you understand the problem. If you just show me the answer and it's wrong, I have no idea if you just don't know how to do the problem at all, or I kind of have to assume you just don't know how to do it if the only thing you gave me was a wrong answer. But if in here you just made a small mistake, I can see it and I can give you most of your credit for the problem. So show me as much as you can. All right, and then when you're done, I like to click submit. You can always edit it after submitting. All right. This is gonna be the last one that's in this mathematical accuracy. I wanna talk about the other 2 types of questions we have as well. Here is the same idea. We're simplifying this. There's just numbers here. We do need to keep in mind our order of operations. But this one has something that's a little tricky, and it has to do with our parentheses. Sometimes parentheses are hidden or implied. And that's true anytime we have a fraction. Anytime you have a fraction like this, the top and the bottom are in what are called implied parentheses. We just have to assume that those are grouped together, and parentheses are a way for us to group them. So before we do any simplifying of our fraction, we need to put together what's on top and put together what's on the bottom. So for this one, I can put together these things, right? 5 plus 3 is 8. 10 minus 6 is 4. Now we can deal with our fraction. Remember, a fraction is another way for us to write division. So really what this is saying is 8 divided by 4. We know that simplifies to be 2. one was actually a really easy problem. The hard part of this one is going to be putting it in. Because I want to type in a fraction, I need to open up my equation thing, and there's a button here that will let you do a fraction. There's also a keyboard shortcut with the backslash. You can just type in the backslash, and it'll automatically make a fraction, but I'm going to do it right here with this button. So we got 8/4, and then that's simplified to just be 2. Not a lot of work to show here, but I can see that you knew you had to put these together first and then do your division. I can see what you were thinking if you type in just these few steps, just this little amount of work. I can see that you knew what you were doing, okay? And then again, submit when we're done. Oh, I said that was gonna be the last one. I misspoke, there's one more. All right, so now this one, we are evaluating an expression. Whenever you see the term evaluate, that means we're going to try to get a single number answer. And usually when we're evaluating, we're plugging in numbers for a variable. So in this case, everywhere there's an x, we're going to put a -6, and everywhere there's a y, we're going to put a -2. So I'm going to try to color code this a little bit, but where the x is, I'm putting 6, and where the y is, right here, I'm putting a -2. And we got to remember that whenever you have a number and a variable next to each other like this, like 2x and 3y, that means those are being multiplied together. So this means 2 times x. Now x is not an x anymore. We're going to replace it with a 6 plus 3 times y. But again, y is no longer y. It's going to be a -2 according to our equation there, right? All of that gets divided by 3. So this is my first step. This right here is called the substitution step. We are substituting these numbers for the variables, for the correct variables. So everywhere there was an x, we put a 6. Everywhere there was a y, we put a -2. Now it's similar to the last problem where we have a fraction that needs simplifying. Before we can deal with this fraction bar, we have to do everything on top and everything on bottom. There's not much on the bottom, so I'm not worried about that. But the top, there's a lot to do up here, a lot of things. There's some multiplication and some addition. Okay, so multiplication comes before addition, so I need to multiply these. 2 times 6 is 12. 3 times -2 is -6. 12 plus -6, we could use a calculator here, or we could remember this. Adding a negative number is the same thing as subtracting. So this is the same thing as 12 minus 6. That's 6/3. 6 divided by 3 is 2. That's funny. We've seen that answer 2 a lot. That's kind of a coincidence, but there we go. There's our answer. And remember to show your work, show all these steps. This one's going to take a little more time to type all this stuff in, so be patient with it. Remember to use your fraction button here to do all this. We want to show all these steps. And then you click down in the denominator there. Hit enter to go down to my next line. Let's type in a new equation. My next step here was 12 plus -6/3. I'm going to go ahead and enter again and put in my next line, which is 6/3. And then our final answer, 2. The more work you show, the more credit you can get. It's certainly possible that you can, with this many steps, and a lot of these problems have multiple steps, there's many chances to make just one small error. And by showing me your work, I know that you understand the process. Even if you make a small mistake, you can get almost all of your points. And submit when you're done. You can edit it if you need to. All right, I keep being wrong about this. I thought this was shorter than this, but we're going to keep going. So here we have another mathematical accuracy question. We have some algebra tiles. Remember, we did a good amount of work with algebra tiles. We need to simplify this expression and explain how the algebra tiles make this happen. So on this particular slide, this one I can draw on here, and I will actually be able to see what you draw. So you can get some credit here by just simply showing how you can put some things together. So I am going to do that. I'm going to say this goes with these terms. These can go together. And I'm going to even change my color just to make it a little more clear. These X's, I'm using my mouse pad and it's a little tricky to do this, but I'm going to do my best. And we can always erase things if we make a mistake. This is right here is the eraser button. I can see how you're putting things together, how you're grouping the tiles that are alike together. And you can even kind of draw in your final answer here. You could show me how you did it, right? By putting these together, by putting the 4 and the -1, we ended up with 3. And then I have 1, 2, 3, 4, 5 X's. So plus 5X. You can do this. You could also type that over there in the box as well. You could show that you did 3 plus 5x for your first part. Remember, this has a second part, simplify, which we just did, but also explain. So here we go. I put together the terms that were represented by the same algebra tiles. I want to make sure to use some vocabulary terms like algebra tiles, put together terms. You know, make sure we're trying to use some of those vocabulary terms. And you could go back to that vocabulary Google Slides that I put together with all the different terms we've learned. You also could use maybe the term zero pair here, right? Because we have a zero pair between the if you want to undo your last drawing, you can click this undo button. You could talk about zero pairs, right? We had a negative and a positive that make a zero pair to cancel out. All these things can be shown by the drawing and talk about how, you know, and make sure we're using the vocabulary terms when we're doing these. When you feel good about your answer, go ahead and submit it. Move on to the next one. Now, constructing arguments is the next type of question that we're going to see. For constructing arguments, we really need to give a thorough explanation. We need to give a full justification of why the problem was answered in that manner and use precise language. So those are our vocabulary terms, making sure we're using really precise vocabulary terms. Not for everything, this isn't a vocabulary test, but making sure we can use some of the right terms and that our explanation is logical, it makes sense, and it's clearly communicated. We're going to need to write more than like 2 words on these. We're going to need to write full sentences, a couple full sentences to answer these questions. I would recommend at least aiming for 2 sentences when you're doing them. All right, let's look at the first one. Explain why the expression A and expression B simplify differently. Okay, so we're looking at these 2 expressions, A and B. For here, I'm giving us some clues of terms that we could use. Make sure to use vocabulary terms such as like terms, add, subtract, zero pair, algebra tiles. You don't need to use all of these, but it's just a hint of some things that might be useful, and you might think of something else that might fit here as well. So, well, this first one, I'm just gonna write things out. So A simplifies to be 3y, right? Because when we subtract that, here, I'll just write the whole thing out. 5y minus 2y equals 3y. And B simplifies to be what? It's 5y plus 2y y. And when I add those together, 5 plus 2, we get 7y. So that's just kind of a starting point. With these constructing arguments problems, it doesn't mean you're not solving the problem. It means that you're doing more than solving the problem. You're also explaining it. Okay. Expression A, we are subtracting 2y. So we will have some 0 pairs when we use the algebra tiles. So I'm writing these things out. These aren't the only, there's not one way to answer these questions. I'm really looking to see what your understanding of the concepts of simplifying and algebra tiles and like terms are in this case. So as long as you're using the vocabulary terms properly and making a valid, real statement here, it's fine. Expression B, we are adding 2y. So we combine all of the y terms together. So just a brief explanation. It took me 2 sentences. They're long sentences, but they're not that bad, but they're clearly communicated. I know which expression we're talking about each time. I'm using some vocabulary terms like subtracting, 0 pairs, algebra tiles, combine. Yeah, lots of different things that are math language. That's what we're looking for here. Okay, and when we feel like we're done, move on. All right, another constructing arguments question. So we have explain the difference between set A and set B tiles. So here are our 2 different sets of tiles. What that means when you try to simplify them. So now, what's the difference and what that means when you try to simplify them? Okay. So what's the difference? I can see really obviously one of the differences. These are x squared tiles. So I have 4 x's. Remember, this is a drawing tile again. So I can draw on these, and I'll be able to see whatever you draw here. So these are 4x, and these are 2x squared. And this is 2. So I'll be able to see this just so that you can kind of identify what's going on here. In A, we have 4x squared, which are not like terms because they do not have the same exponent. So I'm using vocabulary terms. They're not like terms, and why they're not like terms. B, we have 4x and 2x, which are like terms and can be combined to be 6x. So I'm doing both parts. I'm explaining the differences, explaining what they are, and I'm saying what it means to simplify them. So I went ahead and simplified both of these. The first one we can't simplify. Maybe I can say that. So we can't simplify this expression. I noticed that I didn't talk about how to simplify this first expression, whereas on this other one I said they could be combined. I showed what they could simplify to be. Again, using math language, trying to use some of those terms and everything and doing all that. We have about 1 more minute, so I want to kind of go quickly into the last question type, which is called critiquing reasoning. This is where we need to identify an error and explain why that's an error. If anyone hasn't typed their name in the chat, please make sure you do before we end the class. Otherwise, I might miss you on the attendance. All right, so identify the mistake, explain why. I still need to use my vocabulary. All right, here we go. Find the error, say why it's an error. Markian was asked to simplify the following expression. So here we go, we have this expression. For these problems, sometimes it is helpful to do them yourself. So try to do them yourself sometimes. That way you can then compare your work to what's done and see where it's different. So I'm going to do that. I'm going to do this one. I'm distributing this. So I'm doing -2 times 4x minus -2 times 3. Right, distributed it to both of them, and it's a minus in between those terms, so that's where I'm getting that minus. So I end up with -8x minus -6. Subtracting a negative term, anytime we have this double subtraction, remember we can always change that to plus. Okay, so here's what I got as an answer. Now let's compare it here. Okay, so this is the same. Yeah, it is 12:22. You guys are free to go. I'm going to finish this one for the video so that it'll be up there on the Google Classroom, but I'll see you guys on next Wednesday, so be ready for that test. But what's different is this second term. That one is incorrect. It looks like he forgot to distribute right there. So I'm going to go ahead and say that. What is the error? The final answer has -3 in the correct answer should be -8x plus 6. So here I'm doing a little bit of two things. I'm really just pointing out what the mistake is. Where is it wrong? Where is it wrong? It's wrong really in the final answer. That's where the error is happening. I want to explain why this is an error. This is where I get into the details. So it looks like he forgot to distribute to the second term in the parentheses. So he did not do -2 times, oh, maybe I need this, -2 times 3 to get the correct answer. So go ahead and end that there, submit that. With these questions, make sure you're carefully identifying a mistake and explaining why that's a mistake. If you're doing both of those two things, you're going to be getting your full credit. If you're only doing one of them or one and part of it, then you're going to be missing some of your points here. I'm going to go ahead and stop my video and make sure you guys are getting to your next class. I will see you next week.